Hi there, my name is Nicholas Berg. I'm from the state of Rhode Island, and my project title is Impacts of 1,2-Propanediol Effluent Discharge on Reproductive Rates and Dispersion Patterns of Anabaena inequalis and Chlamydomonas reinhardti. In my project, I grew cultures of cyanobacteria and algae in environments containing propylene glycol de-icing fluid, also known as 1,2-propanediol, and compared their reproductive rates with cyanobacteria and algae that had been grown in just regular growth medium without the chemical. I knew from the beginning of the project that Anabaena inequalis and Chlamydomonas reinhardti should not be capable of metabolizing 1,2-propanediol de-icing fluid because they lack the enzymatic equipment in order to begin the reaction. 1,2-propanediol dehydratase is a vital enzyme in cleaving propanediol into propanol, and it was lacked by both organisms. Regardless of the fact that they are unable to metabolize glycol, both the algae and cyanobacteria reproduced up to factors of twice as much as the control bacteria and algae. It also completely altered their physiological properties, including their color, their clumping behaviors, their adherence to the surface, and also their buoyancy. Upon further experimentation on my cyanobacteria samples in much larger vessels to foster longer-term growth, I found that the unusual growth patterns I was observing in the presence of glycol were characteristic of heterotrophy. They were losing their buoyancy, which would keep them close to the direct light source. They were losing their deep green color, which signifies presence of chlorophyll in the environment. And they were also growing in much longer chains with more dead matter in the environment than with control bacteria. The cyanobacteria reverting to heterotrophic behaviors did not make much sense at the time, considering they're actually unable to metabolize a molecule. So I hypothesized that they were actually using the decomposition products of 1,2-propanediol, which can be produced when heterotrophic bacteria break down the molecule or when it just spontaneously decomposes in the presence of oxygen. I later confirmed that hypothesis that they were using the decomposition products and not the glycol itself. And this is a new biochemical property of 1,2-propanediol. The photosynthetic life is actually able to use it as a carbon source. The inference can be made that this carries over into the natural world where glycol is discharged en masse over the winter, and the decomposition products can accumulate over that season until spring. What this merits is a reevaluation of regulations on glycol wherever it's used at airports in colder temperate regions. And it also may imply myriad different environmental impacts that have never been seen before for propylene glycol. Thanks for watching this video.